Hello, welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to quickly just teach you about imaginary numbers. So, previously, we're not able to take the root of a negative number. It has to be square root function. The domain is x is greater than or equal to 0. But we found that there are solutions, like x-intercepts, to a graph, to an equation that are not visible on a graph, but it still yields the correct solution when plugged into an equation. So this old mathematician, he was just studying numbers, and there's this one number that he got, and he kept plugging it in, and it still worked. So he said, well, root of -1, just our base number for the imaginary number system, the root of -1 he called I. So that means I squared equals -1. And again, when we plug these into the solution, they will be correct as like x-intercepts, but they will not be visible on your graph. So if you had something like this, just like your xy axis, if you had, let's say, an x to the 4th or something that changes direction like this. So you have 1, 2, 3, 4, 5. 5 changes in direction. How many of these are like actual x-intercepts visible, real numbers? 1, 2, 3. So we have 3 real solutions, but the graph changed direction 5 times. So this is an x to the 5th function. So that means we have 2 non-real or complex solutions to this equation, which I don't know the equation, but we have 2 complex solutions and 3 real. So let's just start and see. So our equation is, we're finding the x-intercepts of 0 equals x minus 2, quantity squared, plus 4. So we move the 4 over to the other side by subtracting 4 from both sides. So we have -4 equals x minus 2, quantity squared. And now we do a square root. Originally, we would never have said that this equation has any x-intercepts, because you can't take the root of a negative number. But you take the root, it's a plus or minus on this side. Then we have, let's just make this simpler into x equals terms. X minus 2 equals plus or minus root. First, I'm going to simplify what's under this radical. So it's 4 times I squared, because I squared, the root of I squared will just be I. So root I squared, because that's really 4 times -1, which is equal to -4. So now you see it's not a negative under the radical, it's just 4I squared. And we could substitute the I back in later. We're not going to, though. So now what do? Well, we just move the 2 over by adding 2 to both sides. So x equals 2 plus or minus the root of 4 is 2, and the root of I squared is I. So your solutions would be, well, x equals 2 plus or minus 2I. And now you see we can get solutions that are negative. So should we plug this back in? Why not? Why not? X equals 2 plus or minus 2I. Let's see. 2 plus or minus 2I. I'll write this down on the side. 2 plus or minus 2I. So 0 equals 2. Let's do 2 plus 2I minus 2 squared. That's a 4. Plus 4. Now we could just do plus or minus here. So then 0 equals this 2 and this minus 2 cancel each other. Now it's plus or minus 2I squared plus 4. Remember, when you're squaring, like if you squared a negative, that negative is just gone. So it's just 2I squared. So we have 0 equals 2I squared is 4I squared plus 4. Remember that 4I squared is really 4 times -1, which equals -4. So we have 0 equals -4 plus 4. So 0 equals 0. And as you see, we would have said this equation has no x-intercepts, but correctly we would say it has no real x-intercepts. This equation, 0 equals x minus 2 squared plus 4, has two x-intercepts, but they are both complex. So thank you for watching. I hope this introduction to imaginary numbers was helpful, and thank you for watching.